Welcome to video 3, which is page 3, numbers 10, 11, and 12. You will notice I've got some big tables already put in here where I'm going to find segments, slopes, and distances. And then I will do as the problem suggests. In number 10, it says calculate the perimeter, which means I need to add up the 4 distances that I'm about to find. So I'm going to find 4 distances, and I am going to add them all up. So as I take a look at my picture, I could name them by the 2 endpoints, segment AB, but you'll notice this little letter down here. Maybe you can make it out, maybe you can't. That is little A. You'll see little B over there on the right. Little C is kind of that top one, and little D is off to the left. If you want to name them A, B, C, D, I don't care. If you want to use the endpoints, it really doesn't matter. I'm going to start out by finding segment AB. And in order to find the distance, I'm going to start by finding its slope. So from A to B, all right, I'm going over and I'm going up. So I'm going over 1, 2, 3, 4, 1, 2, 3, 4, 5 units. And I'm going up 1 unit. So my slope from A to B, it goes up 1. And it goes over 5, so it is 1/5. And the distance is the square root of 5 squared plus 1 squared. Well, 5 squared is 25. 1 squared is 1. 25 plus 1 is radical 26. Radical 26 is somewhere just over 5. All right, the next segment I'm going to take a look at is segment BC. And I'll change colors here to green. From B to C, it looks like I'm going up 2. I'm going to the left 1. So for my slope, it is rise 2, run -1, which is the same thing as -2 over 1. However you want to look at it, you can put that negative either on top or on bottom or in front. The distance is the square root of 2 squared, which is 4, plus 1 squared, which is 1, and 4 plus 1 is 5. So the square root of 5. And the third segment I need to find is segment CD. Switch to blue. From C to D, it looks like I'm rising, going up 1. I'm coming over 1, 2, 3. I'm moving to the left. So my rise is 1. My run is -3. So this is the same thing as -1/3. And the distance is the square root of 1 squared is 1. 3 squared is 9. So 1 plus 9 is 10. So the square root of 10. And the fourth segment is segment AD. So from A to D, it looks like I'm rising 1, 2, 3, 4. I'm running 1. So rise 4, run 1. And my distance is the square root of 4 squared is 16, and 1 squared is 1. So 16 plus 1 is radical 17. Now, to find this perimeter, I have to add up all of those 4 numbers. So let me jump down here and grab my calculator. Maybe. Maybe. There it comes. Back to the key. Once the calculator pops up, I'm going to make sure that you're okay on how this types into the calculator. So I have 4 distances that I need to add up. The first one is the square root of 26. You'll notice that the cursor is still under the square root, so I'll press to the right. If you don't get the number showing up under the radical and you get that parentheses, make sure you close your parentheses around your 26. Now I need to add another radical to that, so I'm going to go radical 5. And I have to add a third radical, radical 10. And then I have to add my 4th radical, which is radical 17. Those are my 4 radicals from the last one. So it is 14.6204707.8. And the answer, the question says round your answer to the nearest hundredth. So that is the second decimal place. So 14.6, and then I look at the 2. If I look one place past, it's a 0, so the 2 stays. So 14.62. So this perimeter, 14.62 is my final answer for the perimeter around that four-sided figure. You will notice looking at the slopes, we have no parallel lines, so that is not a parallelogram. That is just some quadrilateral. All right, on to question number 11. Calculate the area of the triangle. So the area of the triangle, we talked about this one, about wrapping the triangle in a rectangle, some sort of a rectangle. So let me grab a highlighter here. Okay, and the farthest left point I have is D, so I'm just going to kind of put a line over there on D. The highest point is E, so I'll put a point that goes through E. My lowest point is F, so I'll go all the way down there through F. My farthest right point is also F. I'll go through there. So you'll notice here in the middle, right in here, this is the rectangle that I'm dealing with. So I'm going to figure out how wide is this rectangle. So if I were to count across the top, 1, 2, 3, 4, 5, 6. This is 6 units across the top. As I count down, 1, 2, 3, 4, 5, 6 units down. This is actually not even a rectangle. We know that this is a square. This is a 6 by 6 square. So if I want to calculate the area of a triangle, area is equal to 1/2 base times height. The base of this square is 6, so area equals 1/2. The base is 6 and the height is 6. Now if I were to do 1/2 times 6 times 6, I would get 18 for my final answer. So that area of that triangle is 18 square units, whatever units we're measuring in. So it is 18. All right, on to number 12. Determine if the triangle Tom with vertices, all right, let's graph it. So over 1 and up 5 is T. Over 5 and up 8 is O. And then over 11, my graph stops at 10, so I'll just kind of go over here to 11. That is M. All right, and then I'm going to make a triangle. And it wants me to determine whether it is a right isosceles. Okay, so I have 3 segments to deal with. First segment I'm going to deal with is TO. I'm going to find the slope first. So it rises 1, 2, 3. Around 1, 2, 3, 4, 5, 6. So rise 3. Run 6. So slope 3 over 6, which is 1/2. The distance is the square root of those 2 numbers over on the right. 3 squared is 9. 6 squared is 36. 36 plus 9 is 45. So that is the square root of 45. Second segment I'll deal with is OM. This one's a little tricky because it goes off the graph. But from O to M, it looks like it is going over 1, 2, 3, 4. And then it's dropping down, all the way down to 0. From 8 all the way down to 0, so it drops down 8. You know what? I'm looking at this and I made a mistake. Get rid of this. I plotted this point in the wrong spot. I put O in the wrong place. O should have been over 5. I went over 7. So over 5 and up 8. That looks like a better place for it. apologize. All right, let's try this again. All right, from T to O. All right, so looks like I'm 1, 2 going up, 3, going over 1, 2, 3, 4. That looks a little bit better. So rise 3, run 4. My distance is 3 squared, which is 9. 4 squared is 16. 9 plus 16 is 25. Square root of 25 is 5. Looks a little bit better. O to M. I'm going over 1, 2, 3, 4, 5, 6. And it's dropping down 8. Going from 8 all the way down to 0. So my rise is negative 8 as it goes down 8. My run is to the right 6, and that reduces to negative 4 over 3. Distance, square root of 6 squared is 36, and 8 squared is 64. 36 plus 64 is 100. The square root of 100 is 10. And the final segment is TM. From T to M, it looks like we're dropping 1, 2, 3, 4, 5. We're running from 1 all the way to 11, so that's a run of 10. So the slope is down 5, run 10, which is negative 1/2. And my distance is the square root of 5 squared is 25, 10 squared is 100. 100 plus 25 is 125. And that one does not come out nice. Square root of 125 is not one of our nice distances. So the question is this a right isosceles? Well, in order to be right, I have to have two slopes that are opposite reciprocals. So the slope of TO is positive 3 over 4, and the slope of OM is negative 4 over 3. These two are opposite reciprocals. So TO is perpendicular to OM. So yes, it is a right triangle. Well, the problem says, is it a right isosceles? So isosceles means it has to have two congruent segments. Well, 5, 10, and the square root of 25 are all different. So is this isosceles? No, it is not. This is a right scalene triangle. This is a right scalene triangle. I do apologize for that little mix-up. I'm trying to get these done quickly to get them live on Canvas as fast as I can. So that is the end of page 3.